Heading back to work after lunch with Phil on Tuesday. Mercedes off the starboard bow. Port is left because they both end. Right. The right ends in T. Wait, that doesn't make sense. Let me behind the truck. Question mark. Dimensions. mirror is, except for some reason I smacked it the other way. Sorry. You get the idea. But again, it's at this dimensionality that we exist, which is one layer of dimensionality. I don't think I think in our mathematical models, the idea of negative values is a mistake. Or it's an engineering artifact. I don't want to call it a mistake. I want to call it an engineering artifact that works well for human technology. But I think in terms of modeling the universe, it is flawed. I believe in difference. I don't believe in negative. By the same token, I don't believe in zero. If something would numerically have a zero value, using zero as an engineering concept, what is reality is when you're in math and you multiply by zero, the term just falls out. The term just goes away. It's a missing term. And humans want to keep track that term could come back, so they like assigning it to a zero. Okay, I get it. Again, that's a technology engineering choice. I think that is misleading in terms of thinking about the physical world. There is no such thing as a zero. There may be, I think the lowest value is 1. And there can be ratios, fractions. I don't like fractions. I prefer them to be ratios, not fractions. Because then you get tempted to take 1 and divide it by 3. And you get that dot, 3, 1 and 3 is very simple numbers, but you get this repeating decimal forever. Well, infinite regression, infinite progression, procedural existence. There are ratios, though, this much to that much. But going back to dimensions, the universe at the Planck length, it might be smaller than the Planck length, but that's right in the proper neighborhood. I'm going to say that it is in terms of the Planck length, and call the Planck length the base unit of length in the universe. There's some kind of emergency vehicle seemingly getting closer, but I don't see it. It seems to be getting further. Now it's closer. I still don't see it. Oh, my hypothesis is that approximately some very high percentage of roadside trash litter actually comes out of garbage trucks, as opposed to people tossing crap out of their windows. I have to wager it's at least 75% of the roadside trash. That includes people hauling dumpsters, regular trash trucks. That's neither here nor there. I'm just commenting on the trash truck. It's beautiful yellow and green. Barely smoked at all. Dimensions. I know, I'm toying with you, aren't I? I'm not talking about the dimensions yet. Alright. At the Planck length, I see all of existence as actually not talking about dimensions. There's going to be at least 3 layers of dimensionality here. There's Planck length, then there's human length, going on this order of magnitude, and then there's universal length of dimension. There are 3 different kinds of dimensionality that work together. In fact, the higher order dimensionalities are emergent behaviors of the lowest level dimensionality. But they are not dimensions in the same way as one thinks of a cube. You know, XYZ axis all orthogonal 3 space, right? That is an engineering concept humans use that works enormously well. It does everything that we need it to do for the technology that we have today. It may not cover some of the things that we're doing with quantum computing, but for the most part, it's 99.99 at this point. Again, percentages, right? When we talk about percentages, back in engineering, statistical analysis, the universe doesn't operate on statistics. It just operates, and we measure with statistics, model using statistics. So, okay, there's 3 different kinds of dimensionality, and they are not, I do not believe that the dimensions themselves are double-ended lines, being lines in the true mathematical sense, geometric sense, where there is a rays 180 degrees opposite each other in all dimensional domains, where that defines a line. I believe in rays, essentially, or vectors, right? Maybe they're tensors. Tensors and vectors are, well, you could probably use tensors. But I'm going to speak plainly. Math isn't quite where it would need to be. Or the quanterms. Anyway. So, imagine, if you will, that the universe is a series of nodes, where nodes have connections to nodes, because it's a network. And at the Planck length domain, I'm not saying it's exact, but it's higher or lower roughly, that the tesseract, is it the tesseract? No, the tetrahedron, sorry. The tetrahedron defines dimensionality. I don't even want to use the word dimensionality. It's going to lead back to the 90-degree orthogonal space that we build our houses in. I don't have a better word, so pretend it's this new way of thinking of dimension. Maybe it's not new. I don't know. It's the way I think of it. Anyway. So if you think of a tetrahedron, it has 4 points, 4 nodes. It has 6 edges and 4 faces. Right? So it's 4 dimensionality is how I refer to it. Now, why are those dimensions? What do the dimensions represent? Where are the rays? Because I don't use lines, I use rays on this kind of dimensionality. Well, there's rays that come off of corners, first and foremost. Then there are rays that come off of the line segments, and the length of these line segments is 1, no matter what. They're connected. There are rays that come off the center points of those line segments. That's 1/2. Yeah, sort of. It's not a fraction. It's the center. And then there are rays that come off of all the faces. Alright? And the definition definition of orthogonal is of equal angle in opposition to all edges or faces of the tesseract. No, I keep saying tesseract. Tetrahedron. Alright? So I think of it as 4 rays off the corners, 6 rays off the edges, 4 rays off the centers of the faces. With all the edges of the tetrahedron being of unit length 1, Planck length-ish, maybe below Planck length. I've said this before. I'm going to say it again. Don't know the number. Now, each of these dimensions in the network that is created by this tetrahedron allows it to join with other tetrahedrons. Inevitably, I'm a computer scientist, so I think in terms of triangles for graphics cards, right? Polygons defined from this, but now I have 4, 6, 4 dimensionality to work with, where the bonding strength in each of these dimensions is different. And I've been debating this for a while. What's the strongest bonding strength? It's probably face-face. So if you had a pair of tetrahedrons, when they bound, they would bind most strongly face-to-face, which is essentially, if you took them and you tried to do that, it wouldn't work, because you have triangle, you're trying to make them become one triangle. They don't become one triangle, and they don't snap together like that, because the connections are always length 1. That would be a length 0, which doesn't make any sense, because I don't like 0. I don't like 0. 0 isn't a thing. So that would, the node would lose its identity if you went and made faces merge. And as such, you would lose mass. Or you'd have to have mass 2 edges, which doesn't work. So if you wanted to take a tetrahedron and attach to another tetrahedron, it only requires 1 additional node to connect to 3 nodes of the face, the corners of the face. That's the strongest kind of bond. The second is the edge connection, where multiple ways to do these connections too. You don't bond at a node to an edge. You bond an edge behind an edge. So you take 2 tetrahedrons and allow one of the links from one to go through the center of the other. Now you can't think of this as being a physical thing. It's not. There isn't a volume to the tetrahedron. That's what's going to be a little bit mind-boggling here, because you're going to want to think of it in terms of 3 dimensions, right? You're going to see the tetrahedron. You're going to see the edges. You're going to think of them as having a physical pencil-drawn length. They have a length 1, but it's a logical bond that they have. So these edges. So when you do this, when you have one inside of the other on an edge bond, it is captured. It is captured logically, not. It's physical, but it's not physical the way you're imagining it. And finally, there are the corner bonds, where you can take a tetrahedron and take its vector out and attach 3 points to it, part of what's happening in the universe, which is part of the source of quantum foam, is that these rotations can happen independently. It's very computational. And you have these relative positions changing all of the time, and that is the essence of energy. It is these tetrahedron linking and unlinking, transferring and conveying energy all over the place at the three different kinds of bonding structures: face bonds, the edge bonds, and the corner bonds. Now, if you want to step it up a dimension, so that is not 3 dimensions, right? There are 3 geometric forces, if you will, going on there. Or properties is probably an easier way to say it. Then there's the space that we experience, 3 space. This is the domain of the cube. Works exactly the same way as the tetrahedron Planck-length universe, except it operates on a cubic kind of spatial function. So for a cube, you have 8, 6, 12, right? 6, 12. It's 8, 6, 12 dimensionality. Now, why don't we experience 8, 6, 12 dimensionality? Instead, we see this X, Y, Z. Well, X, Y, Z is actually 6 if you treat them as rays in opposition. So we do see part of it. But we build things, right? We have walls. We have rooms connected to rooms. It starts to actually see things that work like that. We have nets. We have networks of power lines, telephone, internet, cable, whatever, pipes, right? And even world natural cave systems, whatever. Then going to the highest order is 5-sided space. Should we do this off the top of my head? It's 12. Is it 12? 5, no, it's 20. 62, 26. I think that's it. 60. 12, 62, 26 space. And that's the domain of the entire universe. And at all 3 domains, the universe is completely connected and non-locality becomes a challenging thing, because when you're at dodecahedron space, I have a term for it, dodic space, very distant parts of the universe are connected physically in real time, but it's very diffuse. So, I'll get into a consequence of this. Is what happens to black holes? Why do they evaporate? How do they evaporate? Where do they evaporate to? But it's the nature of deep, minuscule tunnels through the universe where everything is connected together, and how it operates at these 3-dimensional domains. There may be, again, we're in the middle, there may be a 6th-dimensional domain, which goes beyond what I'm able to conceptualize or see or observe. So, is there something below a tetrahedron space? You're going to get into flatland at that point. But maybe. I'm not going to outright discount it. But based upon me being in the middle, I'm in the 3 space. I'm in cubic space. My consciousness is a part of cubic space. So I can imagine the higher order and the lower order in the same way I can see the Planck length and the concept of the larger universe, the scales that those are on. And I'll leave it at that for today. I hope you had fun.